Hi, my name is Sarah,
My name is Jessica.
and this is our spring semester of 2019 in EDSE 4212M with Mario Torres, and we're going to be doing our project on law of cosines. So, law of cosines is c squared equals a squared plus b squared minus 2ab cosine c. So we have here a squared, b squared, and then this is going to be our c squared. So our a squared is 3 by 3 inches, and then our b squared is 4 by 4, and then our c squared is 5 by 5.
So first we're going to be proving when the angle of C is 90 degrees. So when we had an angle that is 90 degree, cosine of 90 will be equal to 0 because the x value will be equal to 0. So the area of 2ab cosine C is going to be equal to 0. So now we just had that c squared is equal to a squared plus b squared,
Which is 25.
which is 25. So
And then c
now
plus 5.
by adding b squared plus a squared, we're going to prove that it is equal to c squared. So the first thing that we did was to cut a squared into small pieces. So now we're going to be adding this to c squared. And so we have now that a squared plus b squared is equal to c squared.
So the next case that we're going to be talking about is an acute angle at 60 degrees. So when we move the angle to 60, we can see that it's around like 3.6. And then when we do the math, C does come out to 3.61. And then C squared is 13. So when we subtract 13 from B, like the area 13 from B, we get these two pieces. So we're going to be showing that a squared plus this equals to the 3.61, which fits perfectly right here. So when we add a squared plus the rest of the b squared, we get it adds up perfectly to fit on top of 3.61. And that is what we got exactly from plugging everything in. So our next angle is going to be 120. So we're going to move it to 120, which is an obtuse angle. And then for this one, if we try to complete it to make the triangle complete, it adds up to about 6, like a little past 6 at 120. And then when we do the math, the C is 6.08. So if we want to complete the square, we just add the other side and then complete the square to get 6.08 squared, which is 37. So that has an area of 37.
Okay, so now we're going to prove when the angle of C is 180 degrees. So in that case, we're also going to move the C square and add 2 more inches. And now we get that this length of C is going to be 7 inches. Now after that, we had to complete the square. And so we get a square that is 7 by 7, and so C squared is equal to 49.
And we do the math right here, and it is true that the length of C is 7 when we plug in the values and cosine with 180. And then C squared is 49. Which is what we have over here. So this could be applied to any angle. So we can move it always like 80, 70, 60, and or we can move it to obtuse. So we could do like 140. And if we just move this, we'll just have to add a value right there to complete the triangle, and that will be the length of C, whatever, how many inches you get. And if we move it to like an acute angle, then like at 50, it would be around like 3.1, something around there. So you could just keep moving it, and you could see what length of C you get at each angle of C.
In the general case for the Laplace cosines, we had that c squared is equal to a squared plus b squared minus 2ab cosine of c. So if we had that the angle of c is in the first quadrant, the angle would the value would be a positive value, but because we had a negative in front of the 2ab cosine c, we are going to be subtracting this area from a squared plus b squared. So like in this case, we had a squared plus b squared, so it's the angle gets smaller. The c squared is also going to get smaller. Now in the other case, is we are in the second quadrant, c squared equal to a squared plus b squared minus 2ab cosine of c. Cosine of c is going to be a negative value, and then a negative times a negative will be positive, so we are going to be adding the area of 2ab cosine of c. So right here we had a squared plus b squared, and then we're going to notice that c squared is also getting larger because the angle is greater than 90 degrees. And then just to complete the square, we're going to be adding different pieces in order to get the c square.